Good morning, students. I hope you all are well and doing mathematics comfortably. These days, we people are doing ring. We have defined so many terms and a particular theorem on the ring. We have considered a cancellation law, etc., etc. Let us continue this. I'll just draw a diagram. It looks like hexagon, no? Here I write a ring. Okay, that means a triple with non-empty set and two binary compositions denoted by plus and dot. Then this is commutative ring. This side I write ring with unity. Then I write here integral domain. Okay. Then I write here division ring or skew field. And here I write field. This is the chart I have already explained. Ring is commutative ring if multiplication composition is commutative. गुणन संक्रिया यदि क्रम विनिमय हो तो इस वलय को क्रम विनिमय वलय कहते हैं इन हिंदी. The ring is commutative ring if multiplicative composition is commutative. Means AB equals BA for all A comma B belongs to R. Ring with unity. Unity means identity element. तत्सम अवयव. If the second binary composition, first में कोई गुंजाइश नहीं है, हमें मालूम है. If this multiplication composition has multiplicative identity, means R has multiplicative identity, then we say ring with unity. Then integral domain. Integral domain is commutative ring with ring with unity and one more property. What is that? This is without zero divisors. Always remember. Means AB equals 0 implies A0 or B0. This is without zero divisors. Means AB equals to 0 implies either A equals to 0 or B equals to 0. So what is an integral domain? An integral domain is a commutative ring with unity and is without zero divisors. This is the property. ये इसमें इंक्लूड है, ये मैंने यहाँ लगा दिया है और ये प्रॉपर्टी इसमें एक्स्ट्रा है. What is division ring? What is skew field? Ring with unity, and every non-zero element has multiplicative inverse. रिंग है इसका मतलब सेमी ग्रुप तो है, एसोसिएटिविटी है, आइडेंटिटी मिल गई. यदि इनवर्स मिल जाए तो ये ग्रुप बन जाएगा. कौन सा ग्रुप? मल्टीप्लिकेटिव ग्रुप. इसलिए इसको क्या बोला? स्क्यू फील्ड. यह हमने बोला इसको डिवीजन रिंग. कब बनेगा डिवीजन रिंग? व्हेन G dot forms a group. Multiplicative composition forms a group R, because set is denoted by R, not by Z. So here I write for this one non-zero, every non-zero element has multiplicative inverse. Every non-zero element has multiplicative inverse. Then this is called skew filled or division ring. And in the last I have written filled. Filled means R plus abelian, R dot abelian, and distributive property definitely 100%. So what is a filled? A filled is a division ring if every non-zero element, this is the part of this one, so a filled is a division ring if it is commutative. क्योंकि ये ग्रुप तो है लेकिन अबेलियन ग्रुप नहीं है. अबेलियन ग्रुप के लिए यदि ये प्रॉपर्टी यहाँ बन जाती है इस डिवीजन रिंग के साथ में, सो अ डिवीजन रिंग विद कम्यूटेटिव प्रॉपर्टी, देन दिस इज नोन एज filled. Filled is an integral domain, filled is a division ring, filled is ring with unity, filled is commutative ring, and filled is a ring. So filled is survey server. That's why it is very, very important. Now today we will prove a filled is an integral domain. Okay? You know? A filled is an integral domain. Let R be a field. Let R be a field. We have to prove it is an integral domain. Since it is a field, therefore it is commutative ring with unity, and every non-zero element has multiplicative inverse. It is commutative ring with unity, and every non-zero element has multiplicative inverse. इंटीग्रल डोमेन के लिए मुझे क्या प्रूव करना है? This is without zero divisors. Means if I prove a field is without zero divisors, then I can say the field is an integral domain. Okay, so to prove field is without zero divisors. If I prove a field is without zero divisors, then I can say the field is an integral domain. क्योंकि ये दो प्रॉपर्टी तो आ गई मेरे पास में, कम्यूटेटिव रिंग आ गई, रिंग विद यूनिटी आ गई. ये वाली प्रॉपर्टी मुझे शो करना है. फील्ड के अंदर नॉन जीरो एलिमेंट का इनवर्स मींस मल्टीप्लिकेटिव इनवर्स मौजूद होता है. इस प्रॉपर्टी को लेके चलूंगा और मैं प्रूव करूंगा इट इज विदाउट जीरो डिवाइजर्स. ओके, सो लेट्स सी. Suppose A comma B belongs to R such that A is not equal to 0 and A B equals to 0. कल भी हमने इसी बात को लिखा था कैंसिलेशन लॉ के लिए, आपको याद होना चाहिए. Suppose A comma B belongs to R. Remember, R is not a set of real numbers. R is a non-empty set. Whatever it is. Here R is a ring. R is a triple. R is the system with two binary composition. Okay. So consider any two elements such that A is not equals to 0 and AB equals to 0. The product is 0. Here I have written A is not equals to 0. If I prove B equals to 0, you remember, this is the part of, here it is. What was that? Integral domain. Product of two numbers is 0, then at least one of them must be 0. So here I have supposed A is not equals to 0. So if I prove B equals to 0, then this equation holds, otherwise not. So the aim is to prove B is equals to 0. So now say, since A is not equals to 0, therefore A inverse exists. Every non-zero element has multiplicative inverse in a field because this is a field. Since A is not equals to 0, therefore A inverse exists. Now, AB equals 0 implies A inverse composition, multiplicative composition. In yesterday, if you remember, we have proved this one. This into this one is 0. Now this is A inverse A of B. Associative law holds. So here it is A inverse A, and this is E, identity element. This implies B equals to 0. Therefore, field is without 0 divisors. Therefore, R plus field this is an integral domain. Integral domain. I repeat. A field is an integral domain. Field is the super. Field is an integral domain. Field means it is a commutative ring with unity, and every non-zero element has multiplicative inverse. Integral domain, commutative ring with unity and without zero divisors. So if I prove a field is without zero divisors, then I can say yes, it is an integral domain. So this is the way to prove it. Here I have written it is commutative ring with unity and every non-zero element has multiplicative inverse. This is the part of the field since it is a field. क्या प्रूव करना? Field is a without zero divisors. So I suppose two elements of this such that A is not equals to 0 and AB equals to 0. I don't know about B, but I know about A. This is not 0. Product is equals to 0. So here A is not equal to 0, so we must have B as 0. So this holds, and this is the property of zero divisors, without zero divisors. हम बचपन से करते हुए आ रहे हैं इसको. Product of two elements is zero, then at least one of them is zero. Since A is not zero, so we have to prove B is equal to zero, and this is the way. Since A is not equal to zero and it is a field, so A inverse exists. यदि ये नहीं होता तो A inverse exist नहीं होता, इसलिए मुझे इसको लेके चलना पड़ेगा. A is not equal to zero, so A inverse exists. Now this is equal to zero, then you can see we have proved B equals to zero, so field is without zero divisors, hence it is an integral domain. Now what is the converse? Converse is integral domain is a field. Converse is true partially, आंशिक रूप से converse जो है वो इसका सत्य है. A finite integral domain is a field, we can prove. I write it here. Remember, converse is partially true, okay, not complete true. You consider one example. Converse of field is an integral domain. Converse of this is partially true. Remember, this is ring of integers. And this is an integral domain. Ring of integers, this is an integral domain, the minimum one, integral domain. Set of integers, set of rationals, set of reals, set of complex numbers, integral domain. But remember, this set is infinite. Set of integers, infinite it is. So this is not a finite integral domain. This is infinite integral domain. This is not a field. If it is a field, then non-zero element has multiplicative inverse. Consider the element 2. The inverse of 2 is 1 by 2, and 1 by 2 is not the member of this, so this is not a field. Remember, okay? So here it is. The converse of a field is an integral domain is partially true. So I write a finite integral domain is a field. Here it is finite. Let's is an integral domain. Z5 a non empty set क्या एलिमेंट्स है इसमें 0 1 2 3 4 finite set composition I consider only this multiplication is an integral domain. We have proved it. This is an integral domain. If we prove every non-zero element has inverse, then it will be a field. So let us say 0, 1, 2, 3, oh, multiplication. 1, 2, 3, 4. 2 into 1, 2, 4, 2 3 is 6, 4 2 is 8, 3, 2 is 6, 9, and 12 and 2 it is, and 4, 2 is 8, then 3, 4 is 12, and 1. Look at this. Multiplication of numbers is commutative. Multiplicative identity is 1 here. So this is a commutative ring with unity. Unity is 1. If we multiply any two numbers and the answer is 0, then 100% one of them will be 0. Means if we multiply two non-zero numbers, then the answer is non-zero. Here you find, if you multiply non-zero numbers, here we are not getting any number which is 0. Find this one. 1 into 0, we are getting 0. 2 into 0, we are getting 0. 3 into 0, 0. 4 into 0, 0. But if we multiply any two non-zero numbers, suppose 2 is multiplied by 3, then 2 into 3, that is 6, but it is a multiplication model, but the answer is 1, you can see. यहाँ 0 नहीं मिल रहा है. So it is a ring without 0 divisors. It is commutative ring and a ring with unity. So 100% this is the integral domain property to find. Now we find the inverse. We people know that inverse of identity element is identity element itself. You can see 1 is multiplied by 1, so the answer is 1. So inverse of 1 is 1. Inverse of 2, 2 को किससे मल्टीप्लाई करो कि आइडेंटिटी here are 2, 2 को किससे मल्टीप्लाई किया मैंने 3 से. So inverse of 2 is 3. That means inverse of 3 is also 2. What is the inverse of 4? 4 itself. 4 4 is 16. Answer is 1. So inverse of 4 is 4. So this is an integral domain with every non-zero element has a multiplicative inverse. So this is a field. So the converse is partially true. This is the examples. A finite integral domain is a field, you can say. But remember, in the previous video, I took Z6 also. That is also finite. But that was not integral domain. Here is a prime number. This is a prime number. Then this becomes an integral domain. If it is not a prime number, suppose I write here Z6 and write the element 2. Multiplication modulo 6. Then here it is 3. Then 2, 3 is 6. That is 0. So this ring is with the 0 divisors. And the ring is with 0 divisors. So this is not an integral domain. So keep in mind. Okay, so छोटी छोटी बातें जो है कॉन्सेप्चुअल होती है और आपको इन्हें लिख के रखना चाहिए। वीडियोस को मैं पढ़ा रहा हूँ, उनको ध्यान से देखें आप और नोट्स बनाते जाए। कुछ और टर्म्स हम डिफाइन करते हैं थोड़ा सा। Units, elements in a ring with unit elements in a ring with unity। ध्यान रखना, ये यहाँ यूनिट लिखा है मैंने और यह यूनिट है। यह यूनिट से मतलब है आइडेंटिटी एलिमेंट। कौन सा? मल्टीप्लिकेटिव आइडेंटिटी, एंड दिस इज डिनोटेड बाय 1, मल्टीप्लिकेटिव। यूनिट एलिमेंट जिसको हिंदी में हम एक अवयव बोलते हैं, अवयव एक का, और ये होता है तत्समक अवयव। कौन सा? गुणन। यूनिट एलिमेंट्स इन अ रिंग विद यूनिट। ध्यान रखना है, ऐसा रिंग लेना है जिसमें यूनिटी हो, आइडेंटिटी एलिमेंट हो। कौन सा? मल्टीप्लिकेटिव आइडेंटिटी। Let A belongs to R such that A is not equal to 0. If there exists B belongs to R, B is not equal to 0. A belongs to R such that A is not equal to 0. If there exists B belongs to R which is not 0, such that AB equals to 1 equals to BA, then A is unit element in R. Similarly, B is unit element in R. सीधा सीधा गणित है, लिखने में ठीक है, लेकिन सीधा गणित क्या है? If the product of two numbers is 1, if the product of two numbers is 1, if the product of two numbers is 1, then the numbers are called unit elements. या 1 दिखने में 1 है, लेकिन ध्यान रखना 1 जो है वो मल्टीप्लिकेटिव आइडेंटिटी है, जिसको मैंने 1 से डिनोट किया है। 1 यूनिट मैट्रिक्स भी हो सकता है, हो सकता है। So if product of two elements is 1, थोड़ा थोड़ा ये नहीं दिख रहा कि इनवर्स की डेफिनेशन है ये। AB equals to 1, then A is called the inverse of B and B is called the inverse of A. It means in a field we people know that every non-zero element has multiplicative inverse, means this property holds in field. So other than 0, every element is the unit element in the field. Field के लिए remember every field is a ring and every member other than 0 is a unit element of the field. लेकिन यहां मैं बात कर रहा हूं रिंग की, मैं रिंग की बात कर रहा हूं। दिस इज अ रिंग, this is ring with, definitely it is AB equals to 1 equals to B, so this is commutative. So ring with unity, that is 1 here. Remember, it is not a field, it is an integral domain. Do you find any unit element in this? We people know that. The inverse of identity element is the identity element itself. So 1 and -1 are unit elements in sets, set of integers. 1 and -1 are unit elements. But in set of real numbers, you people know that every non-zero real number has multiplicative inverse. So every element that is non-zero element be the unit element in the set of real numbers. थोड़ी देर पहले मैंने एग्जांपल लिखा था Z5. This is a field. So every non-zero element is invertible, multiplicative inverse. And this Z5, 0, 1, 2, 3, 4. So 1 is the unit element, 2 is the unit element. Why? Because 2 into 3 is 6 and the answer is 1, multiplicative modulo. So 1 is unit element, 2 is a unit element, 3 is unit element, and 4 is also the unit element, because 4 into 4 is 16 and multiplication modulo, so the answer is 1. And in short sense it is a field, baat khatam. So every non-zero element is the unit element. इसलिए कंफ्यूज नहीं होना, ध्यान से देखना है कि यूनिट एलिमेंट और यूनिटी में बहुत फर्क है. यूनिटी मीन्स आइडेंटिटी एलिमेंट, दैट मीन्स तत्सम अवयव, दैट इज multiplicative identity. Okay, so we did that. एक और डिफाइन करते हैं. Idempotent elements in the ring. Let's be if A square equals to A belongs to R, and then A is called idempotent element in R. If A square equals to A belongs to R, then A is called idempotent element in R. Is it clear? See, 0 belongs to Z and 0 square equals to 0. Therefore, 0 is the idempotent. One belongs to Z implies 1 square equals to 1. One belongs to Z implies 1 square equals to 1. Remember, 1 into 1 multiplicative composition holds. So 1 belongs to Z implies 1 square equals to 1. Therefore, 1 is the idempotent. Let us consider Z5. What is Z5? Zero square, 0, 1 square, 1. What is 2 square? What is 2 square? 2 into 2, that is 4. So answer is 4. 3, 9. 3 square means 3 into 3, that is 9. 9 is divided by 4, so the answer is 4. Answer must be in Z5. Then 4 square. Only these two. If I consider Z2, Z2 only 2 members. Only 2 members. So here it is. Now I say, if every member is idempotent, क्या बोला मैंने? If every member of the ring is idempotent, then the ring is called Boolean ring. Boolean algebra पढ़ते हो आप discrete mathematics में, Boolean algebra. This is the Boolean ring. ध्यान रखना, यहां मैंने आइडेंटिपोटेंट एलिमेंट की बात की है. इफ एवरी एलिमेंट ऑफ द रिंग इज आइडेंटिपोटेंट, then the ring is called Boolean ring. So this ring is the Boolean ring. Okay, so here it is. So I hope you have understood the concept of ring and some terminology and how to prove the theorem also. Now it is your duty to go through the whole chapter and try to do the problems on the particular chapter. इसको हम यहीं छोड़ते हैं. नेक्स्ट वीडियो में कल से मैं इसका आगे वाला पार्ट पढ़ाऊंगा, that is known as subring and so on, or polynomial rings. Okay, so I'll consider first the polynomial ring, then subring and so on. So thank you very much. Jai Hind.